So today we're going to learn how to solve some of our somewhat more basic trig equations, where our required steps are pretty short. Usually, and this is all for maybe our last two examples, we want to isolate the trig function. So say like in example 1, we want to get sine of x by itself, right? By itself and positive. And then we're going to use some memorized unit circle values to answer that question. Just remember that we are going to go between 0 and 360. 0 included, 360 not included. Actually, I wrote this backwards, didn't I? No, I wrote it correct. So, and then from 0 to 2 pi, 0 included, 2 pi not included. So, if we're solving, say, our first one here, we need to get sine of x by itself. So we're going to need to subtract 1 over. 2 times sine of x equals -1, and divide by 2. So we'll get sine of x equals -1/2. So essentially, again, we're technically going to be using the inverse trig. So where on the unit circle is sine, the y-coordinate, -1/2? Well, if I go back and think about my all students take calculus, right, where is sine negative? In the bottom two quadrants. And 1/2, if you use your hand trick, your left hand trick, sine being on the right, we would need to leave one finger up on the right to get a sine value of 1/2. So that ends up corresponding to, say, 30 degrees. That tells me we are 30 degrees below the x-axis in each of these quadrants, which in quadrant 3 will correspond to 180 plus 30, or 210 degrees. So there's our third quadrant answer in degrees. And here 360 minus 30, or 330 degrees. Now to convert these to radians, we can use our reference angle here of 30 degrees. That's pi divided by 6, right? 180 over 6. So these will both be multiples of pi sixths. So this is 7 times 30. So 7 pi 6. And this is 11 times 30. So 11 pi 6. So there are all of my answers in both degrees and radians. There are two answers, though. So two answers, just listed in both degrees and radians there. Okay, now number 2 is going to be a little more complicated because our trig value is squared. But just like it says, first thing we're going to do is isolate our trig function. So let's go ahead and add 1 over. And then we're going to want to divide away our 4. So divide both sides by 4. We get 1/4. Now, in this case, we do need to get, just like if this was x squared, we need to do the square root of both sides. So we're going to get cosine of x equals plus or minus. And one of the properties of radicals is that you can separate them over multiplication or division. So we can think of this as plus or minus 1/2. So where is cosine positive 1/2? And where is cosine negative 1/2? Well, where is cosine positive? In the first and fourth quadrants. Where is cosine negative? In the second and fourth quadrant. So in fact, we're going to end up getting 4 solutions here. So if I use my hand trick to find my reference angle for cosine of 1/2, cosine being on the left and needing to leave one finger up, in this case your thumb, you'd put your index finger down. That corresponds to a 60-degree reference angle. So we are 60 degrees away from the x-axis in all 4 quadrants. So this is going to have quite a few answers to calculate here. 4 in degrees, 4 in radians. Let's go. So one of them is just 60 degrees in the first quadrant. 180 minus 60 would be 120. So there's our second quadrant. 180 plus 60 would be 240 in our third quadrant. And 360 minus 60 is 300 in the fourth quadrant. So there's our 4 answers in degrees. Let's write them in radians. So 60 degrees is pi thirds, and these will all be a multiple of pi thirds. So I'll start just by writing the pi thirds And we'll figure out what they're a multiple of. So they're all multiples of 60. This is 2 times 60 for 120. This is 4 times 60, so 4 pi thirds. And this is 5 times 60, so 5 pi thirds. And there are all my radian values. So there it is, 4 solutions given in both degrees and radians. Okay, let's try some more of these. So same exact directions. Now we've got a tangent here. So first thing, let's to get tangent by itself, let's add 1/3 to the other side. So tangent squared of x equals positive 1/3. And then we're going to need to square root both sides to get that square off of tangent. And we can write plus or minus, don't forget when we're taking the square of a variable, 1 over the square root of 3. Well, let's see, square root of 1 is 1, but square root of 3 is going to stay in the bottom, and I'm not supposed to leave radicals in the denominator. So let's rationalize that. Multiply top and bottom by root 3, and we get plus or minus the square root of 3 over 3. Ooh, that looks more like a tangent value we know. So once again, we're looking for where's tangent positive and negative. And just like we did in the previous problem, that's gonna put us in all 4 quadrants. Right? Here's where tangent's positive in quadrant 1 and 3, and it's negative in 2 and 4. And now tangent, these are the ones you should have memorized. The value that corresponds to root 3 over 3 is a 30-degree reference angle. So in each quadrant, we are 30 degrees away from the x-axis. So what are those 4 angles going to be? Well, let's see. In quadrant 1, that's just 30 degrees. In quadrant 2, 180 minus 30 is 150. In quadrant 3, 180 plus 30 is 210. And in quadrant 4, 360 minus 30 is 330. So there's my 4 answers in degrees. If we were going to write them all in radians, 30 degrees is pi sixths. 150 is 30 times 5, so 5 pi sixths. 210 is 30 times 7, so 7 times 6. And 330 degrees is 11 times 30, so 11 pi 6. So there's all of my answers for tangent. Okay, number 4. Finally, these aren't squared, so we don't have to do plus or minus. But I do need to, just like if I had, x on 2 sides of the equation here. Whoops, that's not supposed to be an x. Let's say we had something like this. If we have x's on the opposite side of the equation, just like our cosines here, we'd want to put them on the same side. So let's go ahead and do that. Let's just add this cosine to the other side. So a cosine x plus another cosine x gives us 2 cosine x's. Minus the square root of 3 equals 0. Okay, now that we've combined them on one side, let's isolate cosine of x. Let's add root 3 over and divide it by 2. So I'm going to add it over, which gives me a positive root 3. And then we're going to divide that 2 away. So positive root 3 over 2. So where's cosine positive root 3 over 2? Cosine being on the left if I'm using my hand trick. Well, first of all, where's cosine positive? Let's do that. It's positive in quadrant 1 and quadrant 4. And root 3 over 2, I need to leave 3 fingers up on the left, which means I need to put my ring finger down. And that corresponds to 30 degrees. 30 degrees away in each quadrant. So in quadrant 1, that's just 30 degrees itself. In quadrant 4, that would be 360 minus 30, or 330. So in radians, of course, this is pi over 6 is 30 degrees, and this would be 11 pi 6. So that's 30 times 11. So there we go. There are my 2 answers given in both degrees and radians. Let's try number 5. Well, hey, this is pretty nice. It is already isolated, but it's a reciprocal trig value. So here's how we deal with those. What is cosecant the reciprocal of? Sine. And we're just going to write this as sine and do the reciprocal of this value. So if it's not a fraction, just make it 1. and then do the reciprocal. Now I'm just going to leave the negative sign up top for simplification's sake, but that does put our root 2 in the bottom, and we're not supposed to leave radicals in the bottom, so let's get that out of there by multiplying top and bottom by root 2, and we end up with negative root 2 over 2, right? The bottom is square root of 4, which is 2. So this looks more like a value from our unit circle. So if we do our all students take calculus, where is sign negative, because it's negative root 2 over 2, well, it's negative down here in the bottom two quadrants. And for sine root 2 over 2, that corresponds to your middle finger, if using your reference angle, which is 45 degrees away in each of these quadrants. So let's see, 180 plus 45, that would be 225 in degrees. And 360 minus 45 is 315. And since these are both multiples of 45, they will both be multiples of pi fourths. Let's see, just being less than 2 pi, this should be 7 pi fourths. And this just being more than 1 pi should be 5 pi fourths. Okay, so there are our 4 solutions. This is where cosecant is negative root 2. 2 places given in both degrees and radians. Okay, let's try this next one. Let's subtract 8 over and divide by 4. So subtracting 8 over and divide by 4, we get secant of theta equals negative 2. Well, it's a reciprocal trig value. Let's write it as one we would know. Secant is the reciprocal of cosine. So where is cosine equal to? And flip this guy upside down, negative 1/2. All right, where is cosine negative? Over here, on the left half of our graph. And let's see, if I'm using my hand trick for my reference angle, to get cosine of 1/2, I need to leave one finger up, meaning my thumb, and that would be my index finger, or 60 degrees is our reference angle. So we're 60 degrees away from the x-axis. 180 minus 60 would be 120. 180 plus 60 would be 240. And if we write these in radians, this would be 60 degrees, pi thirds, times 2. And this is 60 degrees times 4. So 4 pi thirds. So there we go. There's my answers given in both degrees and radians. There are 2 solutions. Now our last ones are going to be a little more complicated. I know these were already a little complicated, but look at this now. Tangent squared plus 2 times tangent plus 1 equals 0. So in this case, I can't combine these. These are not like terms, but you might recognize a pattern we see here. Something squared, something to the first power, constant equaling 0. It's a quadratic. It fits the form of a quadratic. And I'm going to introduce you guys to a kind of a higher level idea, and you will use this at some point in calculus to help. It's called U substitution. U substitution. Okay, and you do that by just defining something that's repeated a bunch in your function. It's just to make it look a little bit easier to handle with. So here we're going to say let u, so the variable u, equal tangent of theta. Okay, and that's what's repeated a couple times. Then I can represent tangent squared as u squared. 2 times tangent would look like 2u. Plus 1 equals 0. And now I have something that looks a little more familiar. It's a quadratic, right? And we can try to factor it. You know, worst comes to worst, quadratic formula, but I think this is factorable. Factors of 1 that add up to 2, I think are just going to be 1 and 1. Same signs, both positive, I think even, right? U plus 1 and u plus 1. Those multiply to 1 and add up to 2, and yeah, I feel pretty good about those. So let's go ahead and set each one equal to 0. That would give me u equals -1 and u equals -1. So we get the same solution twice. That's fine. Now we're going to replace u with tangent. So once we've kind of solved for it, we can substitute back in. When does tangent of theta equal -1? And where does tangent of theta equal -1? Of course, it's going to give me the same answer just twice. So where's tangent negative? All students take calculus. Let's see, it's positive in these two. So it's negative here and here. And tangent value of 1 corresponds to 45 degrees, if you remember that from the quadrant 1. So we are 45 degrees away from the x-axis in each of these quadrants. So let's see, in quadrant 2, that'd be 180 minus 45. I believe that's 135. And 360 minus 45 is 315. And if we're going to, now, of course, we would want to solve this one again, but it's going to give us the same two answers, right? They're just duplicates. So these are both multiples of pi fourths. This is, 3 pi fourths? And this would be just short of 2 pi, so 7 pi fourths. Okay, so there we go. So we substituted in u for tangent just to make our equation look nicer, right? Looks like something a little easier to deal with. I don't have to write all these tangents. And hopefully recognize that this is a quadratic we need to solve. We factored it. We set each factor equal to 0. We happened to get a repeat answer, so we didn't have to go through this process twice, but sometimes you might. Okay, let's try our next one. This would be a good one to try out if you want to pause the video and then unpause it in a second, see how you did. All right, here you go. Let's see how you did. So if you let cosine here, we can kind of see that cosine's repeated. One's squared and one's not, so we can't add or subtract them. They are not like terms. So we decide to use a u substitution. Let u be cosine of theta. Then we have 2 times u squared, minus u minus 1 equals 0. So we see we have a quadratic. If you factor this, it should factor as 2u plus 1 and u minus 1. Setting this equal to 0, you subtract 1 and divide by 2. U is -1/2. And from this one, we get u as +1. So substitute cosine back in. Where's cosine -1/2? It's negative in the second and third quadrants. And a value of 1/2 corresponds to a 60-degree reference angle. So 60 degrees away in each of those is 120 up here, 240 down here. Where's cosine +1? In fact, there's only one place the x-coordinate is exactly +1. That's at its maximum here, which happens to be at 0 degrees. Now, or 360, but remember we're excluding 360. We're only allowing 0 here, so we don't get duplicate responses. So there's our 3 answers. There's only 3 answers in degrees, and converting them to radians, we get 2 pi thirds, right? Pi thirds being 60 degrees. So that's times 2. That's 60 times 4. And then 0 degrees is, of course, 0 radians. Okay, that's it. We're going to do a bunch of extra practice in class. This is a great one to make sure you're there and working through problems. It will definitely help before we get to our quiz. Okay, we will spend a whole second day doing more of these, and we'll even look at when you have something like sine of 2x equals 1/2. How do we solve for that? And in fact, this is going to have twice as many solutions as sine of x equaling 1/2. So we'll talk about that next time. It'll be solving day 2, which will be our last lesson.